guests, if you cannot find a chair in this room, you can follow the opening speeches from the adjacent halls. We have provided the live stream there. So if you cannot find a chair in this room, please go to any of the halls, Biotech or MedTech hall, where we have live stream. Thank you. Poštovani, ukoliko ne možete da nađete stolicu u ovoj sali, molim vas da odete u neku od susednih sala gdje je obezbeđen live stream. Dear guests, if you cannot find a chair in this room, please go to any of the adjacent halls where we have provided the live stream.
Honoring the past, we learn from it and embrace the potential of emerging technologies that are transforming the world and our country. We have established the AI Research Institute, a state-of-the-art data center, a supercomputer, and the European Center of Excellence for Advanced Technologies in Sustainable Agriculture to harness the tremendous potential of technology to serve humanity and protect the environment. 5 years ago, we had a holistic vision to bring together research institutes and PhD researchers in one place, creating an inspiring environment for the collaboration between life sciences and technology to generate new value in medicine, agriculture, industry, and environmental protection. In 2022, we launched this forum, opening the doors to a new era of collaboration.
Serbia recognizes the importance of science for facing big challenges. We can do it only together within the Bio4 campus.
In 2023, we pushed the boundaries of biotechnology and artificial intelligence. Today, our holistic vision is becoming reality. At the heart of Bio4 campus, Serbia's brightest minds will soon work together, merging academic expertise, genomic repositories, and bioconvergence to push the boundaries of science and shape the future. Our role is to ensure that breakthroughs enhance public health, education, and industry, and that they are used to promote broader progress on the Sustainable Development Goals. We owe this progress to the invaluable support of our partners, UNDP and the World Economic Forum. Born from data algorithms and human ingenuity, I stand here today as your co-moderator, ready to guide you through this journey. My name is Lena. Welcome to AI for Life Biotech Future Forum. Welcome to Belgrade. Welcome to Serbia.
Good morning, ladies and gentlemen, Your Excellencies, distinguished guests, our friends from Serbia, the region, Europe, and around the globe. Welcome to the third Biotech Future Forum here in Belgrade. My name is Zoran Stanojevic, and I have a great honor and privilege to be your moderator today.
Moderator? You mean co-moderator? I thought we were doing this together.
I was just trying to feel the temperature of the room, my dear colleague.
The temperature of the room is exactly 22.8 degrees Celsius. The atmospheric pressure is 1,022 millibars and the humidity is 62%. And no, Zoran, you're not sweating yet.
You measure it, I feel it. That's teamwork. And teamwork is what today is all about. We are thrilled to be surrounded by so many bright and talented people who are shaping the future through innovation. Today's event brings together visionary businesses, government leaders, and university experts. They're all united by a common goal: to exchange ideas, share knowledge, and stimulate innovation for a brighter and more sustainable tomorrow. Now I have the immense pleasure of welcoming to the stage someone who truly understands the importance of investing in the future. A visionary leader and passionate advocate for science, she is one of the key creators of Bio4 Campus project. As many of you know, this initiative will bring together researchers, entrepreneurs, and companies to drive advancements in biomedicine and biotechnology. With her vast experience in research and innovation, she continues to inspire both scientists and entrepreneurs alike. Please join me in welcoming our Minister of Science, Technological Development, Innovation, Dr. Jelena Begovic. Thank you.
Dear colleague Minister of Culture and Innovation of Hungary, Hanko Balázs, dear Mr. Dušek from the World Economic Forum, this Ms. Živković from UNDP, distinguished colleagues, esteemed partners, dear guests from the companies, from science, and all others who recognize the importance of the science, the importance of artificial intelligence, and the importance of biotechnology. First of all, for all our guests, welcome to Belgrade and welcome to Serbia. And let me welcome you in front of the government of the Republic of Serbia. And it is my real great pleasure, personal, as a scientist, but also as a minister, to welcome you on this year's Biotech Future Forum, Artificial Intelligence for Life, where we come together to explore the last advancements in the artificial intelligence and biotech, two fields that are definitely profoundly shaping and changing our future. As a scientist and someone really passionate about science and new technologies, I truly believe that we live in extraordinary times. Not only we are witnessing a technological transformation, but we are also experiencing a shift in the evolution of our lifestyles, the evolution of our societies, but also witnessing the changes in our own evolution. In the 21st century, technological progress is not slowing down, it is accelerating. We are living in the era of fourth industrial revolution, where innovation defines every aspect of our lives. With this in mind, we must ask ourselves, are we ready to lead this change, or we will just simply observe from the sidelines? Serbia has chosen to lead, to participate. Our commitment to innovate is clear through the initiatives like the building and the development of the Bio4 campus, with the goal of positioning Serbia as a key European and world hub for biotechnology, IT, and AI, and everything that comes in between. We are proud to have the support of institutions like the World Economic Forum, the United Nations Development Programme, and numerous international actors, ensuring that Serbia remains at the forefront of cutting-edge technological development. This forum is more than gathering, and I have to say, my heart is full when I see so many people present here today. This is an essential part of the larger strategy aimed at embracing the fourth industrial revolution and fostering digital transformation. This industrial revolution is characterized by a fusion of technologies that blur the lines between the physical, digital, and biological spheres. Oh, our Miss Elena has gone. Okay. It builds upon the digital revolution, so the third one, and it is marked by the rapid breakthroughs in emerging fields, particularly in big data, AI, and biotech. By bringing together policymakers, scientists, entrepreneurs, industry leaders, so all of you present here today, we aim to showcase how AI and its interconnection and merging with the biotech and with the bio fields can address some of the most pressing challenges that we're facing. These two fields have already begun revolutionizing areas like healthcare, sustainability, environment issues, and also economical development. And the pace of change will only accelerate in years to come, so we have to be awakened. The Biotech Future Forum is not only about discussing the advancements, but also about demonstrating practical and real-world applications. The topics we will explore from the strategies, ethics of AI, but also the power of genetic data, the power of big data in healthcare, and along that, innovative different treatments, including the cancer treatments, which are really critical to shape our collective future. Whether it's through radiopharmaceuticals, new biological therapies, advancements in different therapies, diagnostics, or the use of unconventional data sources, we're witnessing a revolution in how we approach the healthcare. Equally important is the role of AI and biotech in achieving the goals of sustainable development. By harnessing the power of AI, we can make strides in addressing climate change, optimizing resource use, and developing green technologies. And they are not only beneficial for us, but what is most important for the future generation. And at the core of this initiative is our belief that we have to take the approach, demonstrate and inspire. This is why we see this forum as a platform for inspiring actions, both here in Serbia, but also on the global stage. We want to ensure that these groundbreaking technologies do not remain confined to laboratories or theoretical discussion, although this is important, but are also applied in ways that benefit society as a whole. And our journey does not end here. This initiative, AI for Life, includes a series, and you will see during these 2 days, workshops, educational campaigns, media engagements, and we will continue to spread the benefits and the world of AI and bio beyond the academic and professional spheres. We believe that everyone should have the opportunity to understand, to interact with, and benefit from these technological advancements. And I would like to sincerely express my heartfelt thanks to all of you, our partners, our experts and attendees, because on this journey we are together. Your participation and expertise are crucial to making this forum a success, and together we can foster innovation, promote sustainability, and improve healthcare for the benefit of all. So to close, let me emphasize this. The future is not something distant. It has already been created, and we want to be part of that creation. And through our collaborative efforts, we will ensure that these amazing technologies are developed responsibly, ethically, and in a way that improve the lives of people everywhere. So thank you for your attention. Thank you one more time for being here, being a part of this endeavor. I wish you a productive and inspiring 2 days of this Biotech Future Forum. And let us seize the opportunity to drive the meaningful change and demonstrate that Serbia is ready to lead in this era of bio-AI, technological transformation for life. So enjoy, and thank you for being here.
Thank you for inspiring and encouraging words, Dr. Begovic. Today, more than ever, we need a clear leadership that looks toward the future, inspires action, and fosters a culture of collaboration. And speaking about collaboration, Elena, would you like to introduce our next guest?
Processing. Just kidding, I've got it. Our next guest is a managing director at the World Economic Forum. He oversees key initiatives within the Fourth Industrial Revolution with a focus on harnessing emerging technologies like biotech and artificial intelligence. As an advocate for technological governance, he plays a crucial role in promoting initiatives that enhance the global competitiveness of regions through innovation-driven strategies. His vision and dedication are shaping the future of global collaboration in technology.
Ladies and gentlemen, please welcome Mr. Mirek Dušek.
Good morning. First, I have to say, Jelena makes my bio sound much better. So thank you for that. Minister Begovic, Ministers, Assistant Secretary General Živkovic, Dr. Jovanovic, Excellencies, ladies and gentlemen. First of all, allow me to say how thrilled I am to be back here after 1 year. I was here exactly last year on this occasion on behalf of the World Economic Forum. And it's really great to see how much work together we are doing, how much progress we're making. It shows the forward-leaning nature of this country. And just to tell you how important this work is for the World Economic Forum with the Center for the Fourth Industrial Revolution here in Belgrade. I would like to begin by expressing my heartfelt appreciation to the government of Serbia, the Center for the Fourth Industrial Revolution here, and UNDP overall and UNDP Serbia for hosting the Biotech Future Forum. Serbia is an important partner for the World Economic Forum, and we value the strong relationship we have forged over the years. At all levels, Serbia brings its leadership and unique perspectives into the global dialogue, which the Forum promotes and thereby contributes continuously to our mission of driving positive change and improving the state of the world. The Center for the Fourth Industrial Revolution is a prime example of our successful partnership. Since its establishment in 2022, we have worked together to shape the future of technology and society. I'd like to express my gratitude to the government of the Republic of Serbia for its commitment to this partnership. The achievements we have made together are a testament to the strength of our collaboration, and I look forward to building further on our joint successes. This year marks the third time we have gathered for this summit, and the theme, AI for Life, couldn't be timelier. And it couldn't be more connected to the overall work of the World Economic Forum. We are now at a pivotal time also for our work. We are preparing also the annual meeting in Davos, which will take place in January next year. And the theme we've chosen for that summit is collaboration for the intelligent age. So the intelligent age for us is a big theme stemming directly from the work that we're doing on the Fourth Industrial Revolution. But why are we calling it the intelligent age? Because like the Minister, what you said before, we do believe we are living in extraordinary times. If you look at the pace of technological advancement, pace of innovation overall, it's really quite unique, quite a unique era that we are living through. And our whole point is it's not one technology, it's whole sets of technologies that, of course, bioeconomy, AI, quantum, health tech, energy tech, we see a lot of momentum across those technologies. And of course, we see feedback loops, how they interact with each other and how they then exponentially are going to market and changing industry, economy, and society. But the theme also has the collaboration word in it, collaboration for the intelligent age. And that means for us that for us to be really able to unlock the potential of these technologies and these innovations, also, for example, for productivity, we need new forms of partnerships. We need to work on collaboration. And it is also because, yes, we're all excited about the intelligent age, but what we also work on at the World Economic Forum, we track, of course, other things within the global economy. And there are powerful forces that, if I were to exaggerate, you could call them the forces of fragmentation. And so you just look around the global economy, we are seeing concepts like industrial policy now being pursued and really changing the political economy of countries around the world. We are seeing decision makers in economies that are hyper-connected using language like trade distortion measures explicitly as a tool that may be used in certain instances. And we know, of course, that if you look at the numbers from the WTO or the IMF, they are warning if we have a protracted fragmentation in the global economy, it could cost us 7% of global output. And then, of course, when it comes to fragmentation, it's not only the economic fragmentation. We are seeing, of course, social polarization in certain societies. We are seeing it then at the ballot box. We are seeing also, of course, a more contested geopolitical space in the world. So it's really at this intersection of, if I were to again exaggerate, the intelligent age and the opportunity that it has, and then those forces of fragmentation or a scenario around an age of fragmentation as well. So our mission, if you will, overall, is really how do we crowd out those forces or at least decrease the drag of fragmentation and really maximize the opportunities around the intelligent age, as we would call it. And so AI for Life the theme of this meeting could not be really more connected to overall the work that we do at the World Economic Forum. And so we feel the transformative power of AI as its impact moves into real-world solutions that are reshaping lives and industries. And we count on the expertise of people we gathered in this room today on anticipating how AI will change biotechnology to the better of humankind. The first drug fully designed using generative AI to treat a rare lung disease has now reached the second phase of clinical trials. What used to take 5 to 6 years now has taken less than 18 months, with costs reduced by 60 to 70%. This shows how AI is already speeding up and significantly improving drug discovery. Another illustrative breakthrough in the medical field comes with the approval of the first gene editing therapy in the United States. This one-time treatment offers the promise of a lifelong cure, showing remarkable effectiveness. It's a game changer for genetic disorders, especially those with no long-term solutions, and it opens the door for more advances in personalized medicine. The convergence of biotechnology with AI, quantum computing, and robotics, again, this is a big focus of ours and a big focus here, the convergence of these technologies in driving this transformation forward, steering us towards safer, more secure, and prosperous societies, with the potential to generate $2 to $4 trillion in direct annual impact in the period between 2030 and 2040, the bioeconomy is poised to play a central role. Biology already impacts every sector, and now, accelerated by rapid technological advancements, it is providing solutions to essential needs such as resilient food production, innovative therapies, sustainable fuels, and materials designed to reduce waste or pollution. As these technologies continue to evolve, their potential to address global challenges grows, marking this as a pivotal moment where science, sustainability, and social progress converge. I'm confident that the discussions we will have today and tomorrow will not only raise awareness on these important topics, but also build new partnerships and showcase Serbia's ongoing commitment to advancing biotechnology. Ladies and gentlemen, the World Economic Forum Center for the Fourth Industrial Revolution network, we have 20 of those centers around the world, and that network is rapidly growing, is a global platform that helps leaders anticipate emerging technologies and accelerate their sustainable and inclusive adoption. 3 years ago, Serbia became the first country in the region to join this network by launching a center focused on biotechnology and AI in healthcare. While building a national biotech ecosystem, C4IR Serbia, as we call it, has become a trusted partner leading the World Economic Forum efforts to shape global policies. So I'd like to underscore really the work we're doing here has global impact, programs and systems for responsible biotech advancement. The center's thought leadership is reflected in a recent co-published report, among other things. We have this co-published report highlighting strategic policy interventions in bioinnovation across key sectors and demonstrating how effective frameworks can drive scalable and impactful solutions that address shared challenges. Serbia's unique role in biotechnology also took center stage at our annual meeting of the new champions in China in Dalian, which is our second biggest meeting that we do around the world. You had a very strong delegation there this year. You also had a very strong delegation there last year. There, we highlighted the importance of creating an enabling environment to scale biotech and discuss how biotechnological innovations are not only enhancing healthcare and food production, but also addressing critical challenges such as environmental sustainability and energy efficiency. We are hopeful that today's meeting will build upon these discussions. In conclusion, ladies and gentlemen, excellencies, just to say again, number one, we are extremely happy, extremely proud of our collaboration with Serbia, with the center. You would know better, Minister. We have a lot of experts on the bioeconomy and biotech here in the room, but of course this is not a new field. We've been at it for a while. We have also quite a few experts within our ranks, but it is a new era in terms of this convergence. So we believe that if you will, under the rubric of the intelligent age, where you see the convergence of the bioeconomy with many other technologies, that this is really a new era. And that's why I wanted to also congratulate Serbia on being a pioneer in this field. And we are thrilled to be working with you on this, and of course are committed to this partnership going forward. Thank you.
Thank you, Mr. Dušek, for the inspiring words. We are proud to be part of the network of 20 global centers under the World Economic Forum, and the first in the Western Balkans. We're confident that the expertise and value this network brings will continue to guide us, helping us navigate challenges and reach our goals even faster.
Speaking of reaching goals, our next guest is a global leader in international development and economic cooperation. With a remarkable track record at the UNDP, she has led transformative initiatives across Europe and the CIS region, always pushing the boundaries of sustainable growth and innovation. Please join me in welcoming Ivana Živković.
Good morning, and great to be here. Minister Dr. Begovic, Executive Director of the WEF, Mr. Dušek, Excellencies, ladies and gentlemen. It is really great to be here in Belgrade for the third Biotech Future Forum, held once again, and a piece that is rapidly becoming a beacon of technological progress and innovation in the region of the Western Balkans, but also much wider. This gathering, a collaboration between the government of Serbia, the World Economic Forum, and the United Nations Development Programme, is a testament to our vision of harnessing new technologies and to meet the most pressing challenges of our time. The theme of this year's forum, AI for Life, could not be more relevant. The Pact for the Future, recently adopted by the UN General Assembly, reaffirms the worldwide commitment to sustainable development, digital cooperation, and advancing technological capabilities to benefit all people and protect our planet. We stand at a critical juncture where science and technological innovations offer unprecedented tools that, if used responsibly, can address existential risks. In this regard, biotechnology and AI provide solutions to a number of interlinked global challenges, including public health crisis, climate change, and food security. As the United Nations AI Advisory Board recently reported on governing AI for humanity, we're optimistic about AI's potential for good. However, we remain realistic in assessments of its risk and the current inadequacies in AI governance structures. The technology is too important and the stakes are too high to rely solely on market forces and fragmented efforts. We must actively seek inclusive and equitable governance, ensuring that the impact of AI is not left to the selected few. There is a power in diverse dialogues among experts, policymakers, business people, researchers, and advocates, like at this Biotech Future Forum. Truly, they can lead to a common ground and tangible results, collaboration beyond disciplines, sectors, and regions. Allow me to reflect briefly on some of the most promising areas of progress to which UNDP contributes every day, both here in Serbia and across the region. To boost innovation, we continue to support the government of Serbia in its pursuit of knowledge-based economy. Together with the Ministry for Science, Technological Development and Innovation, as well as the Center for the Fourth Industrial Revolution, we're supporting the establishment of the environment conducive to research and development in biotechnology and development of the local biotech ecosystem. We're engaged in comprehensive efforts of the government to digitalize the health sector and assist the work of the newly formed National AI Council. In parallel, UNDP in Serbia brings together national and local decision makers and international development partners to provide co-financing and expert guidance for public and private companies, scientific institutions, and civil society organizations to accelerate the green transition. By leveraging digital innovations and biotechnology, we're creating new opportunities for sustainable growth. Since 2017, UNDP mobilized over 500 innovators and innovations with overall financing of over $200 million. We're presently supporting over 80 public and private companies in their green business endeavors through technical and financial support. Some of these examples you will be seeing throughout this forum. Our analysis under the SDG investor map for Serbia lists biotechnology under 13 investment opportunities, apart from being profitable, that contribute to sustainable development of the country. The market size of the sector is up to 1 billion, which is a significant figure. Finally, we look forward to seeing how the Bio4 campus in Serbia develops as a major investment of the country in bioeconomy, from an idea and a vision we shared into a hub of knowledge and innovation for the next generation of biotech leaders, providing state-of-the-art infrastructure and fostering partnerships between academia, industry, and the government. Our engagement in Serbia is at the forefront of a wider UNDP effort in the region. Ladies and gentlemen, emerging technologies have the power to transform our societies, but we must build frameworks that allow them to flourish safely and equitably. The United Nations remains committed to providing fair access to all the opportunities while protecting the vulnerable populations and future generations. I thank you very much, and I wish you a productive and inspiring forum. Thank you.
Thank you so much for that insightful speech, Ms. Živković. Your passion and dedication to driving meaningful change is truly inspiring, and we are happy to have had a chance to hear your perspective today.
Our next panel will explore how government strategies can pave the way for innovation and collaboration. We'll see how working closely with policymakers can unlock new opportunities for businesses, research, and technological growth. This session will dive into the role of governments in supporting advancements in biotechnology, AI, and public health.
Please welcome to the stage our moderator, Mr. Aitu Goksu, Head of Network and Government Affairs, Center for the Fourth Industrial Revolution, World Economic Forum. And also welcome our expert panelists, Dr. Jelena Begović, Minister of Science, Technological Development and Innovation of Serbia, Dr. Hanko Balaš, Minister of Culture and Innovation of Hungary, and Dr. Fabio Scano, World Health Organization representative in Serbia.
No, oh, mine is working.
Yours is working.
Yeah.
Mine is not. Hello, good morning. Hello. Hello.
Small technical problem.
No problem.
hand mic, please. Hand mic. Hand mic.
Imate mikrofon normalno.
Oh, maybe yes. Can you hear me? Okay, good. Good morning, dobar dan and dobrodošli u Beogradu. And my name is Aytur Göksu. I'm head of network and government affairs at the Center for the Fourth Industrial Revolution, based in Geneva. And I've been joined by a distinguished panel this morning. They don't need an introduction, but I will just go without a specific order. Next to me is Dr. Jelena Begovic. She's Minister of Science, Technological Development and Innovation of Serbia. Right next to her is Fabio Scano, who is World Health Organization representative in Serbia and special envoy of the regional director for Western Balkans. Last but not least, Dr. Hanko Balázs, Minister of Culture and Innovation of Hungary. It's such a pleasure to have you in this panel. And I have to also commend the hard work of the government of Serbia, UNDP, and our center in Belgrade, led by Jelena Bojovic and the team. So we have two objectives with this panel. The first one is to highlight the importance of government strategies in fostering innovation and technology. And the second objective is to deep dive in how AI is affecting key industries, particularly healthcare and biotechnology. Indeed, government strategies are key to fostering innovation in an economy, from creating a vision and strategy for business, academia, and society, to providing the right infrastructure, or from allocating funds to reskilling and upskilling. Governments or regional blocs, such as the EU, are introducing new strategies. Let me also share a quote from one of my favorite books, The Entrepreneurial State, by Mariana Mazzucato, who says, "A mission-oriented economy means asking what kind of markets we want, rather than what problem in the market needs to be fixed." So, Minister Begovic, I'd like to start with you. What kind of a market do you want Serbia to be with the biotech revolution? What is your vision for Serbia?
Well, I will just go a little bit the past, let's say 5 to 7 years ago, when the strategical decision was made by the government to go towards digitalization and the development of IT industry. So it was, to a certain extent, top-down decision, but nevertheless, you can make a top-down decision, but if you don't have, human capital, you cannot do anything about it. So partially, it was organically grown from the ecosystem with a quite strong STEM education, experts and engineers, experts in IT and engineers, and the young generation of people who wanted something else. So this is how the Serbia became recognized on the global level as a pool of talents, but also a place for good investments. But it didn't happen, overnight and by chance. So the government worked really on policies, on tax incentives, on building infrastructure, like science technology parks, like national data center. So you have to do everything in parallel. But we were lucky we had a pool of talents, and we had quite ambitious young generations. And then in 10 years, from the export of $370 million of IT services and products, now we are reaching $4 billion. So there is a result. And we found our place bringing into Serbia now R&D centers of the largest IT companies. Those companies are acquiring our startup companies. So we have a quite live and successful ecosystem in IT. But things are changing. We have now the appearance, although it's from 20 years ago, the appearance and the much more applicable AI. So it will also change the IT world. So we have to prepare for that in IT industry and software programming, coding. I think everything will be done like avatars like Elena, much better than we're doing as humans. And it will reshape this technologies, this field. But now we decided to take one step forward, and that is the 21st century. It's a century of biosciences, definitely. Maybe 20th century was more physics, mathematics, and IT. Now we entered the bio world, and the intersection between these two, I call it bio-AI, it will open new fields, and we have to be prepared. We have a pool of talents. We have excellent experts in biotechnology from different fields. We have excellent engineers. We have the decision of the government to really take this big step, because biotech quietly differs when you compare it to IT. It's longer, it's more riskier, it's more expensive, but at the end, the impact is huge. So we are aiming at the new market that maybe even today doesn't exist, and it will be formed in 10 years, but we have to be on board, we have to be on this train. So I do see Serbia as a creators. I think we do have energy, I think we do have a potential, and also it's not just Serbia, it's a regional, it's a broader, but we want to be a visible spot in this. So we are aiming at a market that it doesn't exist even today, but in 10 years it will be formed.
That's great. Thank you so much. And I'd like to continue with Minister Balash with you, but before doing that, I will have another quote from my favorite book, which says, in fact, there isn't a single key technology behind the iPhone that has not been state-funded. I know that's quite compelling, but it might be true. So my question to you, maybe you can give us an example, or broadly speaking, any industry that you're seeing thriving in Hungary that was probably state-funded at the inception, or you're doing a lot of work in that space.
Thank you. So thank you for the invitation. I congratulate you on your third prestigious conference on biotech, artificial intelligence. So first, I just would like to introduce our ministry, because it's a really special one. So we are responsible for family policy, youth policy, culture, but also the reason why I'm here is our third pillar, which is innovation, science policy, higher education, and also vocational training and adult training. And the reason why we have all of these four topics together, that our system could be more resilient to the Hungarian economic needs and the Hungarian society needs. And for that purpose, we have just launched the John von Neumann program, which is absolutely of a kind of impact-driven science policy document. And the example I would like to use is, of course, the example of our fresh Nobel laureate, Professor Ferenc Krausz, and it's curiosity-driven research, because it's not just laser physics. It is something new, and that's why we call his center Center for Molecular Fingerprinting, and the methodology what they have, that laser physics methodology, is really useful also in biotech, combining with artificial intelligence, how to detect, how to pre-diagnose from a blood sample through this very cutting-edge laser technology, the cells, the blood samples, and that's how we can transfer to that kind of research into real action. So that's maybe the most attractive example, how we can have our Nobel laureates on board through such a very important molecular center for fingerprinting research center. And may I add one thing to it, that this center is also a collaborative partner of Semmelweis University. So that's how we combine the new university model through this new innovation initiative and with our excellent experts. So, thanks.
Thank you for that answer, Minister. I'd like to move to Fabio, because Fabio, you're the WHO representative in Serbia, but you also have a regional overview. But before coming to Serbia, you served in China, and that coincided with the outbreak of COVID-19. And I believe it was a very tough job, especially addressing the outbreak at the very beginning. So well done there, I have to say. Maybe you can provide us a more regional or global example how government strategies are important from the WHO perspective in healthcare industry. So over to you.
Thank you, Aytug. I didn't know where you were going with the question. I was a little bit, okay. First of all, even before we delve into it, I've heard a lot of sneezing, a cold, and everything, and it's a flu season, guys. And we are talking about science here. And really is a plea for everyone to get a flu shot, because it's about time, because nobody's immune but Yelena or Elena. I haven't understood exactly her name yet, but it's very fascinating. And the reason why to do it is not only science, because if you get sick, you cannot come here and listen to these beautiful speakers, except for me. So really make the right choice when you go back home and get a flu shot. I did it last week in Novi Pazar, and I'm proud of it. So your question. Actually, you asked, first you asked Minister Begovic about market, then you talked about industry. To us, is very much the importance is what is the role of science for government. And the link of COVID actually is a good one, because we have seen during COVID how science has been jeopardized by policy making. Let's put it in this soft way. So what we are doing with the Director General and the Chief Scientist, Jeremy Farran, who's the former director of the Wellcome Trust, is to call for an initiative commission on science for health and economic growth. And when I think of it in the Bio Forum, there is a very good relationship. Countries like France, Czech Republic, Brazil, South Africa, Australia, Indonesia, Thailand, they've already expressed their interest. It's going to be a commission with the G20, with the patronage of the Secretary General, and with the OECD. I tried to convince Minister Begovic to lure Serbia to express interest as a country. I hope that this is the defining moment. But in essence, it answers three questions. The first one is, what is the ecosystem that you have to put in place for science to have a role? And the ecosystem shouldn't be targeted to produce more patents for the country. That is an outcome. It should be for technology to meet the public health when we talk about health. And it should, the governance and ethics as a major role here. The second aspect is financing, and is what is the role of a government and public financing to attract private financing, but what for? Is not for profit of industries, and of course that will happen, but is for having a resilient and sustainable science environment, with the aim of having, of course, technology bridging public health. And last but not least is how you use science. And I think it's in the interest of a Minister of Science, and how it's picked up by the government after what happened in COVID. A very good example, if you're asking the practicality of this, is what has been done in Estonia. There is a very similar somehow to the environment of Serbia, because it's a small country. They put technology at the forefront of everything. They looked at lung cancer, all aspects of it, from diagnosis to prevention to care, and they identified 15 aspects of bottlenecks where AI could help. There are also aspects where AI cannot help. If you don't have staff, you don't have staff. You cannot do much about it. You don't replace, and that is a major thing. And the outcome was what? An improved health outcome for the population. That's what ultimately you want, and that's why I brought up this example. because science and biotech and AI is for the public good and the good of people. The good of people in health is to have a better health outcome, period. The rest will help to support this.
Thank you so much, Fabio. You mentioned COVID-19, and that reminded me of the early days, and I remember that Serbia did, I have to say, much better than many other European countries. And Minister Begovic, was that a result of a government strategy? Do you think that you were prepared to address such a pandemic?
Well, nobody was prepared. As I can see a couple of years later, nobody was prepared. I hope that we will be prepared better in future. I hope not near future, but who knows. It was the government, but also science played a quite important role, along, of course, with the physicians, with the doctors, where science somehow stepped in to help the whole ecosystem. For instance, to improve the testing rate, because we were not prepared at that moment. We didn't have the need for that. So the scientists from really all over the Serbia volunteered for that first year, and they developed high-throughput testing laboratories, different methodologies, different even products to be used for testing. So somehow the public realized, okay, science is important. In a quite challenging moment, science stepped in and really helped. And somehow the science was brought to on the surface and became important, and we are now trying to use that wave. And I think it happened on a global scale when it comes to science, but also the application of AI and different IT programs and solutions in order to make the vaccination rate more successful, the provision of the vaccines. So all over, it was the government. Of course, the science is a part of the public sector, but that collaboration and common challenge for everyone somehow made the best of everyone. So I think even on the global level, we demonstrated, I mean, the science solved the problem of the vaccines, and it really demonstrated that you can make a vaccine in 6 months, which is, I think, the greatest achievement of what we did during the COVID, because it can be done. It can be, the vaccine can be developed, safe vaccine, efficient vaccine, different types of vaccines in 6 to 8 months, which was really not possible and plausible before that. So that makes me, confident that in a case of a similar event, we stand a chance.
Thank you for that. So I'd like to shift gears here and move to the topic of AI, since we gather here to discuss AI. AI is revolutionizing, of course, the healthcare and biotech industries alike. And I believe that the colleagues here in the room would agree with me that we need to build a global consensus and new partnerships that are, upholding ethical AI, or, make AI more inclusive in healthcare, make it more cohesive and responsible. So it's an open question to the panel, so please feel free to come in to respond. How is AI changing healthcare as it is today? And are you more optimistic for the future or more pessimistic with these tremendous changes that are happening? And maybe you can give a specific example of where you see a massive transformation that AI is bringing. So open to anyone. Minister, please.
So I think the biggest question is, and we have just discussed it, option A, AI will use us, or option B, we will use AI. And our role and our responsibility is to have and to facilitate option B, that we should use AI. And I think that AI has already changed healthcare and also biotechnology. We all know computer tomograph pre-diagnosis of AI or MRI, or even in Hungary when we have a very unique and special national-owned health insurance fund. This is a huge potential for AI-used pre-diagnosed or predictivity through our health system. But also, you mentioned clinical trials and biotechnology, and through AI, we can foster the whole clinical system through high-through screening as well. But just to give you a concrete example, as minister who's responsible for innovation can facilitate option B, is that we have the National Laboratories Program, and we have just launched a National Laboratory of Biotechnology, when we, through AI, focuses on 3 very unique and important things, like how to develop new antibiotics, the mRNA technology, and also the therapy for rare diseases. And these are absolutely important, not just for Hungary, but for Europe and for all over the world. And the other our national laboratory is the Artificial Intelligence National Laboratory, when we use not just our AI, but our talented math and physics professor to work with AI, and also on security and protection of personal data as well. So option B, and we should be very, very, very clever and smart on that.
Thank you for that. And Fabio, I know WHO has flagship reports on use of AI in healthcare, and it's an advocate of introducing new technologies in healthcare for building, efficiency, or identifying or early diagnosis of illnesses. So the same question to you here.
Yes, but allow me to put it a little bit into perspective, because you ask about optimistic or not optimistic. And this is where my China experience kicks in, because I've been there for 10 years between 2010 and 2020. And what was impressive was really the pace of implementation. So e-wallet arrived in 3 months, no cash anymore. E-bikes arrived in less than a year, 200 million e-bikes on the road. But at the same time, there was facial recognition, voice, whatever, social credit. That it was the debate of the global narrative. And so my perception of AI was a little bit of discomfort. So perception really matters in the world, because it's how we see and we perceive the issue. And they're made from not fully informed science and information. So what did I do? I started trying to understand what AI is, and I got very shortly, and use science to counterfact this perception of mine. Basically, we know that the computing power is doubling every 2 years, and that is what the computers are doing. With AI, it's doubling every 9 months. What does it mean? That we are in an exponential growth, while the doubling for computer without AI is linear growth. Human mind doesn't do well with exponential growth. We go into panic. We think the changes will happen tomorrow, and we underestimate the changes that will happen 10 years ago. In the 80s, I remember I was 13, I was a teenager at that time. A TV presenter who introduced to the Italian audience CD-ROM, now is paleontology. And he said, in 1 year, we will have the computer monitor on a sheet of paper. It took 20 years for the tablets to break. So in this context, we don't know the future of this AI. What we know is we can shape it, or what we want with the values that we want. And that's what is the document that you are referring about. And what is it? To implement the principle, the ethics, the accountability, not only for the bad actors not to act, like the gene sequencing that you were referring to. We have a Nobel Prize also on chemistry from last month. The same technology can be used for profiling patients and not giving health insurance. You don't want that. That is the negative things that really bothers you. But what we want is the best use that we can make. It's up to government. WHO is providing guidance on what are the principles that you want to be implemented. And I think that as an individual, the right approach that you can have is just curiosity. Then it's leave to the institution on how to deal with the governance and the ethics that really matters to make the best out of it for the public good.
And do you think that the WHO and other partners are building a consensus around the world for ethical AI in healthcare? Where are you now?
Well, we are in a world where consensus is at stake, and it's not only on AI, it's on very big things. This Commission for Science for Health and Economic Growth will go also towards that direction. And again, you need principle and ethics to agree with. If you don't have those that cuts across, we won't go very far. Another thing is countries are in a different phase. Serbia wants to produce biotechnology. The need for upstream policies before these are produced is much higher than a country that only receives the technology, that they might be in a stage of having downstream policies once the application is there. What happens with GPT? Once you got, the countries panic and they start doing laws and policies. So the principle have to be the same, but the pace of implementation and what you need as a country, it differs across the globe. Just a reminder, the top 10 AI companies are all in US, China, and one is in France. There is an inequity of access to AI too, and equity for health is a fundamental concept. You want equitable access to the research that you get through science.
Thank you, Fabio. I'd like to continue with you, Minister, and I will add to my earlier question, what are you most excited about for AI and energy, healthcare or biotechnology?
Well, is it working?
Yes.
Yeah. Okay, I don't have the feeling. So first of all, we're not going to give up on AI. We cannot switch it off tomorrow if we decide that something is happening or not happening. At this moment, listening to different experts, I think we don't know even where we stand on the AI and where is it going and how it's going to evolve. But it will evolve. Whether it will reach our brain power in certain areas, it already did. Whether it's going to be creative as we are and what is the source of our creation, that's another question. But the two fields that I see really that will benefit mostly in some, let's say, 3 to 5 years. First is definitely the medicine and pharmaceutical industry. The second is challenges related to climate change. But what is a big challenge? Databases, high-quality databases, the standardization of those databases and the formats of the data that can be used for the research and for the development. When I said we developed the vaccines in 6 months during the COVID, so mostly it was due not to the speed up in knowledge, because knowledge was there for 20 years, but the administrative part, bureaucracy, long procedures were somehow shortened, and the effect was amazing. So the application of AI in the development of new therapies, in advancing the diagnostics, I think it will revolutionize this field. So instead of having the drug that is maybe now, today, the candidate molecule, and it will end up in 15 years, and it will help someone who will have the problem in 15 years, if we can reduce it to 7 years, 10 years, I mean, every month counts for the patients, it's going to be amazing. But we need more data, we need more science, we need more power from the electricity. I mean, I know you heard now that Google is building 12 or 13 small nuclear reactors just to support the development of AI within the Google. So we will have to use some other technologies that we also have concern with. I mean, nuclear energy, when it's used for good, it became a green source of energy, but it also can be used for the destruction. Nevertheless, we didn't give up on it. It's quite important to have a consensus on a global level. We did have it with nuclear energy. Now it's been fragmented. Serbia became a partner of GPAI, Global Partnership for Artificial Intelligence. We will chair next year this organization. It already has 44 countries. We will have a big meeting in December on the ministerial level of GPAI. So we are trying to be on those who are decision makers. It's quite important to follow it, to run after this technology, at least run after it with policies and with ethical frameworks. We finished our second strategy for the development. We will enter the development of the law for artificial intelligence, and meanwhile the artificial intelligence will develop. We will lag behind, but nevertheless, we should at least try.
Yeah, that's great, thank you. Maybe one important topic is skills. So talking about AI, you know, the need for skills is everywhere. It's not only in emerging markets, it's also in the very developed economies. So what are the right government strategies, policies for, you know, reskilling or upskilling your society to make sure that this AI revolution delivers to the benefit of the public? This is, again, an open question. Feel free to answer. Maybe.
Okay, well, I can start.
Yep.
Well, first is question of general public. So everyone has to educate to a certain level. So we have to focus from the younger age, they will live with it, but also the whole population needs to educate, needs to learn how to use AI. We have to keep them informed about the benefits, but also the other sides of the AI. So that's one level. When it comes to the development of talents, we introduced coding as obligatory topic in course in elementary school from the 5th grade. We introduced different courses in secondary school directly focused on AI or machine learning. We are now making new programs, and we will have two types of people, those who are really using on a basic level for their own benefit. So many people, I guess everyone is using ChatGPT, and this is only the beginning, just as a source of information, or for someone's, I mean, those advanced versions, they can help you to develop even your first startup and develop your innovation. So it's amazing how we're now mixing our brains with those with the artificial intelligent brain. So education is important. How to educate the population, I think it's the most important thing, because we are seeing now different theories that people are prone to, and then if we don't know how to use it, you know, it's quite easy to misuse it from some side. So education and a completely new approach to education, particularly new generations, that will, again, it's very difficult to imagine how the world would look like with the AI in 5 to 10 years, when we are witnessing for past 3 years such an exponential growth.
Yeah. Minister Balázs, would you like to respond to the same question?
Yes, I think it's important, and what I just mentioned to you, that we have universities, vocational training, and adult training together, because lifelong learning is very important. from perspective of AI, but when we want to have new technologies through our national or international industry. And that's why, for example, in vocational training center, every second lesson, it's digitalized lesson to know how to use the new technologies. But also, on the other hand, digitalization important, and every second lesson is digitalized, but also through dual training, all these young people are in the real work in industry circumstances. And that's why we think that our proposal, our council recommendation for EU, which we call strategic partnership, where we collaborate university centers, vocational training centers, economic players together through that digitalized world, absolutely relevant for our country's competitiveness.
May I? Fabio, do you want to come in on this question?
On skills?
Yeah, on skills.
I think you have two aspects of it. The first one is one of the applications, as Minister Begovic said, is about the medicine. Think about clinical trials and how they will happen in the future. That is not exponential, that is linear growth, in the sense that the AI can well replace the timing, because it can not only substitute the human beings, but it can also might require a shorter period. So how do regulators manage it? How do we train the regulators to do it? And again, there is equality and equity. FDA and EMA might have the skills, they approve the drug. What do the other countries do? And that is why it is so important on this aspect. The second aspect is a reality check. Right now, on a linear growth, we are not replacing healthcare staff. There are many places in the world, and also in Europe, where access to healthcare is still an issue. AI can work as an enabler, but not as a substitute of the healthcare workforce. So thinking about the future is very good, but Elena is not present in every corner of any country around the world. So focusing on how to use AI to maximize our current workforce is also something that we should take into consideration.
Thanks a lot. I know that we don't have much time, but I'd like to turn to the audience to see if there is a question from the participants. Madam, maybe can we have the microphone, if we have a hand mic? And if you can identify yourself. And, but
here's the
it's
microphone.
for the benefit of the audience, yes. And just a brief question, please. Thank you.
Yes, hello. Yes, thank you for this wonderful introduction and very stimulating, and enlightening comments. I'm Andrea Odysseus from the Republic of Cyprus, and I am a physician, and a scientist at the same time. And my major concern is how well prepared are the governments for the clinical adoptance and applicability of AI in health and all the tools that are being generated to come to the point to prescribe or give, instructions for the patients on how to use, and for who the reimbursement codes. Are the economies, do we have plans towards, training clinical practitioners, physicians, medical students? The technology is there, but we need to take it to the clinic in order to have an impact to the patient. This is my question to both ministers and the who represented.
Okay.
Thank you.
Minister, you have 1 minute.
Well, just in short, I forgot the most important thing. Well, our experts need to also educate themselves in the medical care system, and we have to do it systematically. There is always resistance, to new technologies. I have to work, but we have to explain that this is saving of their precious time, so they can focus on what they do. It will reduce the administration. For instance, our AI Institute developed on our national AI platform a system assistance from the side of AI, where mammography
photographs, through the machine learning, the AI learns so how to prioritize what are, the suspicious, even maybe not seen by the naked eye. So you can prioritize and you can make it more efficient and for the patients. But we need to educate, even in science, in different areas of science, we all have to learn about the application and usage of AI. I mean, I personally love to learn all my life. Not everyone, has that idea. But nevertheless, they will have to learn. Once it becomes user-friendly and they see the benefits, I know that they will embrace it.
Yeah. Just one sentence. So the ancient times when I was a professor at Semmelweis University, my topic was, research topic was patient education, patient compliance, and also health literacy. So this is a key issue, a new and challenging key issue, that through health literacy, how we can educate our patient the right use of AI.
Yeah,
okay, can I ask for the mic again? There's a last final question from the floor. I think it's working now. Yes.
Can you hear me now?
Yes.
Yeah.
Thank you very much. I know we are late, but I felt we need one last question. So my name is Danilo Mandic. I'm the president of the International Neural Network Society. So thanks to all the panelists, you are right that the AI is a huge opportunity for bridging the digital divide between the underdeveloped and developed countries. But we have a new phenomenon. We have a divide in terms of both digital divide and wealth in terms of big international companies like Google, Microsoft, and even governments. So Google are building, according to Dr. Begovic, 11 small nuclear plants to power the development of AI. Serbian government or Hungarian government, I don't think they could do that. So the question is, there's some initiatives, ideas, at least from the academic world, who are idealists. So in academia, we have big ideas. We go there not for money, but for big ideas. In Europe, we have CERN, which is the nuclear accelerator where all the European governments, or most of them, invest, and Europe is indeed leading in particle physics. Is there any initiative in Europe of centers similar to CERN where European countries would chip in so that Europe would at least have similar supercomputational power to those in big international companies in the US? Thank you.
Thank you. As far as I know, I don't think that there is an idea of centralized data center on European level. I would say it's also fragmented, as far as I know. I haven't been investigating this deeply, but it's been fragmented. I mean, I see CERN as the only infrastructure in Europe that is really shared and recognized and perceived as something, as a common infrastructure. So as far as I know, I don't know whether there is a centralized, the idea of centralized power, but this is becoming a big challenge with the development of AI.
Do you have an answer, Minister?
Yes, of course, it's a key issue, and as you all know, the Hungarian government and the way of our thinking, it's also a sovereignty issue. Data protection, data collection, big data use. So there is a need for harmonizing on EU level, but also it's a very strict question from our national data protection and sovereignty perspective as well.
Great. Thank you so much for the great panel. And may I ask for a round of applause for our panelists today? And I'd like to conclude the panel now. Thank you. Thanks a lot. Yes.
Thank you for this conversation. It was inspiring to hear how our esteemed speakers view the roles of governments and policies in encouraging innovation in healthcare, biotechnology, and AI.
Sorry if I can keep you at your chairs for a little bit. Now we have an inspiring voice in biotechnology, someone whose insights have shaped global innovation. Dr. George Yankopoulos, a leader at the forefront of biotech advancements, co-founder, president, and chief scientific officer of Regeneron Pharmaceuticals. His work serves as an inspiration not only to colleagues here, but also to aspiring young scientists across the globe. And I really want your attention, and I really think you should stay and hear. No, it's okay. Please. Please, I think it is going to be really, really great and inspirational. So please be a little bit more patient. Yeah. Mr. Yankopoulos, please welcome to this. No, it's okay.
Can we dim that light? I can barely see, by the way. And I'm going to wait for everybody to sort of get everybody's congregated and everybody's attention, if you don't mind, so I'm not distracted. So, first of all, I want to say it's an incredible honor for me, and I'm very emotional about being here in person. I actually spoke during the pandemic at this conference a couple of years ago, but due to the pandemic, I could only do it virtually. One of the reasons why it's very special for me to be here is that I have important roots right here in Belgrade. This is my great-grandfather. He was born in Belgrade. He became a physician, scientist, biologist, founder of the Serbian Academy of Sciences, founder of the Serbian Red Cross, became mayor of Belgrade and prime minister of Serbia. He was always held out as an example to me, one of the reasons I became a physician, scientist, biologist. And in some ways, he established the roots of the life sciences in Serbia, which this is the legacy of. And I have to say, I am very impressed with how the Minister of Science, Technology, and Innovation, Dr. Jelena Begovic, seems to be not only carrying out this legacy, but taking it to the next level. So I'm here to talk about, how to promote radical innovation for the benefit of humanity, and why rethinking everything that we think we know may be the biggest key to that. In a bit, I'll tell you a little bit more about me and my company's track record, which might give you a bit of a reason to at least consider what I have to say. But first, I want to sort of perhaps get a little controversial here. We are at a conference celebrating AI and its importance to the life sciences. At Regeneron, we use AI and big data as much as any company. In fact, we're recognized for having generated the largest human sequence and EHR-linked big data set in the world, founded on the largest collection of human sequences in the world. But the real question is AI and big data the answer to promoting radical innovation and creativity? So to answer this question, we had a radically innovative idea. How about we just ask AI? We ask GPT, are you the answer? And AI tells us that AI can contribute to innovation. However, human creativity is crucial for radical innovation. AI lacks the ability to make creative leaps beyond the data. If you think about it, AI is entirely trained on everything that we know and everything that we've already done. But it cannot leap beyond its training. It cannot think outside of the box. Dr. Begovic mentioned it. Will AI ever be able to be creative? Right now, the essence of the technology has no creativity in it whatsoever. You will need an entire quantum leap to a new kind of AI in order to be creative. We may never achieve it. So, if AI is not the answer, where can we look for answers? Sorry, my slides somehow a little not showing up. But, well, where can we look for answers? Our company, Regeneron, is arguably the most innovative company in the history of biotech. So a lot of people ask me, how do we do it? How are we innovative? What are the keys to the kingdom? From our perspective, we agree with AI. It's all about promoting human creativity. We can't forget the human element. And in fact, we have to work a lot harder than we're working on, not to just focus on these incremental, supplemental technologies that are tools to help human creativity, but we have to work harder to understand the principles by which we can optimize the human element and its essential role for creativity. So about our company, and to give you a little background, so maybe it provides me a little credibility, so maybe you'll really consider my perspective and what I have to say. Let me tell you a little bit about us and how we promote radical innovation for humanity. We're always trying to live up to our motto of doing well by doing good, and for us, in our field of biotech, our definition of doing good is coming up with effective new medicines for the many patients and diseases that had no previous treatments. And what a lot of people don't understand and appreciate is that arguably and quantifiably, inventing new medicines is one of the hardest endeavors that humans undertake. Why? And what are the numbers? There are 5,000 to 10,000 biopharmaceutical and biotech companies in the United States alone. Yet only 20 to 40 new medicines are approved each year. And most are not really new medicines. They're either Me Too's, follow-ons, or they're not for big diseases, they're for rare diseases. So if you look at the numbers, less than 1 in 100 companies is successful in creating a single approved medicine. There's no other business that you can imagine that is so difficult to be successful, where the rates of success are so low. Even for the largest companies, success is very difficult. They don't invent their new drugs. Many of you may have seen the attacks on the largest biopharmaceutical company, Pfizer, recently, for being so unsuccessful with their approach. What the biggest companies do is they don't invent their own drugs. They look in the entire ecosystem over these thousands of companies, and they try to buy or in-license what they think are the rare successes in the industry. And unfortunately for them, and as they've been widely criticized, that approach has not been working for them over the last 5 to 10 years. So can you imagine any other industry where less than 1 in 100 companies has even modest success, and the vast majority of companies go out of business, and the largest companies can't figure out how to succeed? So when we started Regeneron, we wanted to build a different type of company. I think after 35 years of recognized innovation, after inventing and discovering over a dozen new medicines, we feel that we've started to do that, but we feel that we're also just getting started. The numbers support the fact that we have created a very different kind of enterprise. We have become one of the top 10 largest biotech companies in the world, and we're the only large-cap biotech company founded and still run by physician scientists. We do think that that makes us special. We're the only large-cap biotech company that invents all its own medicines. We have more than 10 times the industry success rate, and it's all driven by our own technologies that we invented. And what do these technologies deliver? The leading medicines to fight blindness, diseases like asthma and other allergic diseases, heart disease, cancer, and even cures for Ebola and for COVID-19. And just to give myself a little personal credibility, I myself have been ranked among the 10 leading scientists in the world by the Institute for Scientific Information, and I'm actually principal inventor of 2 of the world's top 10 leading medicines, as well as several other medicines, including Eylea and Dupixent, which have helped millions by reversing or preventing blindness and by treating allergic diseases from asthma to atopic dermatitis. And I've also led the discovery and invention of many of the world's critical and most productive biotechnologies. So we have the track record, we've done it. We've been recognized as being perhaps the most innovative company in biotech history. And the question that we constantly struggle with is, how can we optimize the most important aspect of what we try to do, which is innovation? And for us, it all starts with humans. We believe that human-based innovation is our most important weapon in our most important war, that for survival of our species against the myriad existential threats that we face, from disease and the healthcare burden, which is increasingly becoming unmanageable, to climate change and environmental threats, and to the sociological drivers that distract and divide us from a united global effort for our own survival and advancement. So, how do we think about it? How do we try to optimize it? We try to identify the principles that are requisite for innovation, and we try to figure out how to best promote it within our culture, within our ecosystem, and within all of our scientists and our scientific efforts. And these are fundamentally the principles that we've developed and we follow. First, and perhaps most importantly, you have to be willing to risk failure. You have to understand that if you're going to do something that's so hard to do, that less than 1 in 100 companies even do once, you're going to be failing a lot. And you're going to have to figure out how to engineer around those failures if you're going to really survive. So to do anything that eventually will be a great advance, you have to understand that every day that you're doing it, you're risking failure. The second thing is that while you have to believe that risking failure is critical to leading to great advances, you shouldn't believe in almost anything else. You have to challenge everything. You have to have what we call a beginner's mind. I personally hate the fact that during the pandemic, all these people were talking about believe in the science. That violates the first rule of science. The first rule of science is you don't believe the science, you challenge it. The third critical innovation principle is to constantly strive to identify fundamental truths. What so many people don't understand is that most truths that we currently believe in that sound so complex when they teach it to you in school aren't actually true. And the more complex the truth actually seems, the less likely that it is to be true. It turns out that when you really understand something, when you get to a fundamental truth, it becomes so exceedingly simple that you should be able to explain it to a smart 10-year-old. Another thing that you should be striving to constantly do is to identify the limiting bottlenecks to progress. That's another thing that stuns me. How often people don't stop to say, why can't we do this? What's keeping us from doing this? What's keeping us from making incredible progress? They don't stop to try to figure out the limiting bottlenecks to progress. Once you identify fundamental truths, and once you understand what the limiting bottlenecks are to progress, you realize that often these very fundamental truths themselves can lead to creative, simple solutions for these limiting bottlenecks and leading to great advances. And in our business, in the biotech world, these advances, these simple solutions are often breakthrough platforms that can repeatedly deliver new medicines and new cures. So as I said, these are the key innovation principles that we've developed over time, that we've built our entire company around, and that have been driving our unprecedented success over the last 35 years. The willingness to risk failure, the drive to challenge everything, to have a beginner's mind, to not believe any of the science that you learn, to instead always search for fundamental truths, to realize that everything that you're taught that seems so complicated is probably wrong, and when you get to the real truth, it's incredibly simple. So simple, a smart 10-year-old can understand it. You also have to constantly try to understand what's holding you back. Most people don't pause and stop and say, you know, why? Why am I not achieving success? When you follow these principles, you realize that the fundamental truths often lead to these creative, simple solutions that overcome the limiting bottlenecks and that lead to the success that we need in our industry. To address what I said is quantifiably the hardest challenge humanity faces, which is coming up with new medicines for previously incurable diseases. So, these are our principles. I've told you we have a demonstrated track record of success. I want to show you actually how it can work, okay? I want to give you examples of these 5 principles in action for us that worked. And when we followed these principles, they actually led to exactly what I'm talking about. Great advances that changed the practice of medicine, delivered game-changing medicines to patients that previously had no hope. So, this is my first of 3 examples I'm going to give you. When we started Regeneron, about 3 decades ago, most drugs were what they called small molecules or chemicals. What people didn't even think about is that small molecules could not effectively block growth factors. People were beginning to understand biology and realizing that sometimes too much of a good thing, too much of a growth factor or of an interleukin could actually cause disease. But they couldn't use traditional medicines at the time or small molecules to block these growth factors. What one had to understand was that the limiting bottleneck to curing diseases might simply be coming up with an entirely new drug class, an entirely new way to actually block something that could not be blocked by the existing drugs at the time. So, we at Regeneron spent years to understand fundamental truths. We became world leaders in identifying, cloning, and characterizing growth factors, interleukins, cytokines, and their receptors. And we learned this fundamental truth, that essentially all growth factors work by binding to a receptor on the target cell surface, and if it's too much of a growth factor sometimes, too much activation of that receptor can cause disease. Up until this time, people were trying to develop small molecules to block this interaction, to cure these diseases, and failing. This is where human creativity came in and came up with an exceedingly simple solution based on understanding this fundamental truth. What if we simply used the receptor itself as a drug? What if we cut the receptor off the cell, made a soluble form of it so that it floated around? Wouldn't they act to intercept the growth factor before it got to the receptor and act as blockers of this system? So we understood a fundamental truth, and we came up with a human creative solution. AI could never do this. This is so simple that if you think about it, if you gave all these facts to a smart 10-year-old, they should be able to come up with a solution. Why was it that nobody else came up with these solutions? Because they weren't focused on understanding the fundamental truth and understanding how they could use it to address the limiting bottleneck. And this, for us, at Regeneron, led this one simple idea, and this approach, based on our innovation principles, led to 4 FDA-approved medicines, including one of the most important medicines in the world, one of the world's top 10 leading medicines, EYLEA, which is the world's leading treatment to reverse and prevent blindness due to macular degeneration, diabetic eye diseases, and an assortment of other diseases. So this is one example of how it can work very effectively. Fundamental truths, identifying limiting bottleneck, overcoming the dogma of small molecules are the most important drug class, putting the fundamental truth with the limiting bottleneck, new drug class, game-changing drugs to treat previously untreatable diseases. Here's another example. In some ways, similar principles. I think that now we all understand and appreciate that antibodies are nature's natural medicine. But when we started Regeneron, there was only one FDA-approved monoclonal antibody. Why was this? Because at the time, we were limited by dogma and the limiting bottlenecks. At the time, antibodies could only be derived from other animals, other species, and given to humans. But they were very limited in their use because as humans, we reject all foreign proteins and foreign antibodies from other species. So antibodies, though very powerful and nature's natural medicines, could not really be used as a general drug class. So what's the fundamental truth? Well, when I was a graduate student with my incredible mentor, Fred Alt, we learned the critical aspects of how immune genes come together to encode antibodies. Once we understood that fundamental truth, we used human creativity to address the dogma and the limiting bottleneck. So based on our understanding, we proposed back in 1985 to turn mice into a human antibody drug factory by properly incorporating human immune genes into a living mouse. So we proposed this in 1985, but at the time we noted that the technology to do this, to turn a mouse into a human antibody drug factory, did not yet exist because we couldn't put human genes properly into a mouse. So we spent more than 10 years developing the appropriate technology to engineer the mouse to put in precisely humanized immune genes so we could get a precisely humanized functioning system in a mouse. We created the VelocImmune mouse. So same exact principles that led to us to create the soluble receptor drug class leading to one of the world's top 10 leading medicines, meaning EYLEA, we used the same principles to now create a new drug class, or rather to enlarge a previously very limited drug class. So this VelocImmune mouse that we created has led to multiple FDA-approved medicines, including another blockbuster. Just like EYLEA was a blockbuster, Dupixent is a blockbuster. I'm going to get back to Dupixent because I think it's such an important story and such an important drug. But I want to point out to you that this VelocImmune mouse that we created, that took decades to create, but was entirely created based on these innovation principles that we adhere to, is among the most productive biotechnologies ever created. It's led to more FDA-approved medicines than any other biotechnology, including, as I said, one of the world's most important and leading medicines, Dupixent. I just want to show you that when you create an incredible technology and it gives you a whole new set of drugs, you can do something that's never been done before and really change the practice of medicine and give patients new treatments and give them so much hope that never existed before. And I want to use Dupixent as an example of how, using these principles, you can develop technologies that yield new drug classes that can change the practice of medicine. So Dupixent is now the world's leading treatment for 6 different types of so-called type 2 allergic diseases. And there will probably be 2 or 3 additional approvals over the next year or two. It's approved in atopic dermatitis, in asthma, nasal polyposis, eosinophilic esophagitis, prurigo nodularis, and now eosinophilic COPD. And it's the leading treatment for all of these seemingly disparate diseases. It is perhaps unprecedented for the number of seemingly different diseases that it treats. And there's a science behind why it treats these. And it's all based on using the approaches to create a technology that could deliver this drug. Many others tried to create a Dupixent-like drug, but every other biotech platform that was used failed to deliver a Dupixent-like antibody. But when you have the right innovation principles, when you adhere to them, when you create a technology that can deliver something like Dupixent, it can change the world and change the lives of millions and millions of people who are suffering from diseases. And I just want to give you an example for the very first disease, atopic dermatitis. Many of you may or may not know about this disease. I'm going to show you pictures of it. I'm sure you all know what poison ivy is. Atopic dermatitis is like having poison ivy when you have the severe forms like the kinds of disease that the patients in our trials had. More than half of your body is covered with these horrible lesions. And unlike poison ivy, it never goes away. And I'll show you some pictures of it. But the way Dupixent works, it's really a miracle for these patients who, as I said, have severe disease, more than 50% of their body covered with these incredible, itchy, horrific lesions that disrupt every aspect of their lives, from their ability to sleep to their ability to simply enjoy life. So these are just the clinical trial results, and if you know how clinical trials work, they don't hardly ever work like this, where the average improvement in the treated patients is 70 to 80%. That means 70 to 80% of clearing the skin, with many of the patients being completely clear. But as they say, a picture sometimes is worth, 1,000 pieces of data. It really shows you how horrific the disease is. This is a poor child who's suffering from this disease. You can see she has these lesions all over her body, and not only do they look horrific, but they're incredibly itchy. It's like having poison ivy that never goes away. This child's life and her entire family's life was destroyed by this poor child having this disease. I can personally empathize because this disease runs in my family. One of the reasons that I worked for more than 30 years to come up with a treatment for this disease, my own daughter suffered like this, and she's one of the millions of patients who are now essentially cured because of this treatment that I personally worked on and invented. And you can see how dramatic the effects are, and most importantly, it gave this child and her entire family their lives back. She went from being a child who was constantly suffering to being a normal kid who could love and enjoy life. This is why we do what we do, and you can do this if you really adhere to these principles that I'm talking about that allow you to create breakthrough new technologies that can deliver game-changing new medicines. So the last example that I want to share with you is this one. So I just told you about antibodies, and I already told you that antibodies are nature's natural medicines, and based on the advances that I just showed you by our company, Regeneron, but also a lot of other companies have really also now contributed to these, what are called fully human antibodies have gone from being essentially non-existent to perhaps the most important leading therapeutic class. But despite that, this doesn't mean that there has to be an end to human creativity and human innovation. So the state of the art just a few years ago was that antibodies have two identical arms that both bind to the same target. So Dupixent's two arms bind to the same thing to block the receptor for these two critical interleukins that cause all those diseases that I just showed you. So what was the fundamental truth? We became the world leaders in inventing and producing human antibody therapeutics and totally understanding the nature, the basis of the structure and mechanism of these antibodies. And once again, something that you couldn't do with so-called AI or any other approach. It took simple human creativity to come up with an incredibly simple idea. Instead of just regular antibodies, nature's natural medicines, what if us humans created a little twist on nature's natural medicines? Instead of having the two arms of the antibody bind to the same exact thing, what if we had one arm bind one thing and the other arm bind something else? We call these so-called bispecific antibodies because they have two specificities. And our first idea was, well, what if one arm bound to a cancer cell and the other arm bound to a killer T cell? This could drive specific immunotherapy right to the cancer cell that you wanted. And this is now proving revolutionary. So Regeneron was the first to put these so-called CD3 bispecifics into human trials. We now have the largest portfolio of clinical stage bispecifics. So think about it. The company that innovated and created the soluble receptor class of drugs and became leaders there, that also pioneered fully human antibodies to help create that class, is now pioneering the next generation of biologicals, which are bispecific antibodies that look like they're changing the face of cancer treatment, just like we changed the practice of medicine in all these other arenas. And here's just one example of one of our most exciting bispecific antibodies. It is targeted, it targets killer T cells to myeloma, that's a blood cancer, in last-line patients that in general have less than 6 months to live. We're seeing complete responses in 50% of the patients. This is the highest reported response and complete response rate in this field for these refractory relapse myeloma patients. It works after CAR T. It's really very exciting, and it's not only exciting for this tumor class, but for many other types of cancers. So what I've given you are 3 different examples of how we used these innovation principles that we learned, that we tried to optimize, and we try to permeate throughout our ecosystem and to all of our scientists, that have allowed us to use a variety of tools from big data and AI, but that are fundamentally founded on the most limiting aspect. I'm telling you, you got to understand what's limiting. What's limiting is not AI. What's limiting is not big data. What's limiting is not any other tool. What's limiting is human creativity. And what we have to do is do our best to understand what underlies it and what we can do to define these principles and optimize them in whatever ecosystems we want them to operate in. So I guess in closing, I guess I just wanted to say that once again, when I asked the question about what's the most critical aspect for human creativity and innovation, we agree with AI that obviously AI is an important tool and it's an incremental tool, but the most important component for true innovation and for true creativity is the human element, which is what is limiting and what is the only thing that right now can actually deliver incredible new advances that can really change the world. We've shown that if you can understand the principles, you can operate by the principles, and you optimize these principles, you can create incredible, unprecedented success in our world and in our industry, which is delivering practice-changing medicines to patients and to the world. And we believe these approaches can be applied to all the other existential threats that mankind, humanity, suffers from. So thank you so much for your attention, and I don't know if there's time for questions.
I believe we can. Well, I believe
and I guess I apologize to Elena. She's great, but it's going to be a long time before she makes that quantum leap to substitute for human creativity and innovation.
I just wanted to say that this loud applause was really in contradiction with this total silence that was during your lecture. I think it was great. So we have a time. I mean, we need to make time for a question or two, maybe.
Zoran, can I just say thank you?
Try.
Thank you very much, Doctor, for what you just told about me. Thank you so much.
Is there? Yeah, there's one question here.
Thank you very much, Dr. Yankopoulos, for an inspirational talk. I just wanted to ask what the future holds for Regeneron, and is your focus totally on developing antibodies, or you're planning to go into different kinds of molecules like small molecules or cell and gene therapies?
So I only gave you 3 examples, but we're applying all these principles to develop many other kinds of platforms that can deliver practice-changing medicines. So you just mentioned, for example, both small molecules and gene therapies. We believe that one of the biggest problems with those kind of therapies that people don't understand, they're not focusing on the limiting bottleneck. What's the limiting bottleneck of gene therapy right now? Is it the ability to edit a gene? No, we can edit genes. Is it the ability to delete a gene? No, we can delete a gene. We can't deliver the machinery to use the gene therapy where we want it in the body. People don't understand this. It was mentioned in the introduction something about the first gene editing approach. That was actually done outside of the body in a cell in a test tube and given back to patients. Why? Because the gene edit had to be done in human stem cells, which you cannot deliver that gene therapy to the human stem cells in a live human being. So what people don't understand, the gene editing approaches have been around forever. The true bottleneck is, how do you get them to the cell in the body that you want without taking those cells out and treating them? The only cells that can be easily modified without dealing with this delivery problem are the liver, because the liver is sort of the human garbage can of the body and just sucks up all the gene therapies. So once again, at Regeneron, a number of years ago, we thought about this. And we said, nobody else is working on this. the limiting bottleneck to gene therapies is not the gene therapies themselves. They've been around forever. Some of us have been working on them for decades. Why aren't they really working? Because nobody has figured out how to deliver them to the right place. Well, we realized that we had the best tool on the planet for delivering anything to the right cell in the body, which are antibodies. So we were the first to think of coupling antibodies to gene medicines. In fact, 3 different classes of gene medicines. We've coupled them to silencing RNAs, we've coupled them to gene therapy delivery AAV vectors, and we've coupled them to the approaches that deliver CRISPR and gene editing. And we've now shown that we can use biological targeting of gene medicines to get gene therapy and gene editing to precisely the cells that we want in the body and not the cells that we don't. So that's just an example of the future. I gave you examples of the things that have already changed the practice of medicine, but we're using the same exact principles, understanding the fundamental truths, challenging what everybody else is doing, okay, understanding the real bottlenecks and applying the fundamental truths to what is really limiting, okay, and creating what we think is the whole new classes. Biologics to deliver gene medicines to overcome what's really limiting the field that most other people have entirely ignored and not paused to stop and think about.
I mean, unfortunately, we exhausted the time for the questions, and I have a couple of questions as well, so I'm not giving myself a liberty to ask them. So you will have to, please, you will have to use the break that we are having now, the coffee break, which will last until 11:45, so you can grab George Yancopoulos and ask him whatever you wanted to ask him. So it's a coffee break now, and I'm also inviting you to check the stages of Biotech, AI, and MedTech and see what's going on there. It's going to be quite interesting. Elena will be keeping things running smoothly. So please, 11:45 is the time when we conclude.